All right, let's get this going. So welcome Dennis, Roberto, Venti, and Mani. I think we have only a few. I think we will be joining, given it's a workday and it's almost 4:30 here in Singapore. So super excited to restart the whole CNCF Singapore. It's been cold for a while. And today we have a great agenda with introduction to Envoy and one of the graduated projects along the side of Kubernetes and Prometheus, the known names. Uh, my name is Harish. I work for Kong and I'm ex-Red Hat. So I'm the lead organizer for CNCF Singapore group. Just warming up, the group is still small. Feel free to ping me if you're interested in any ideas in the future. So I'll be moderating this webinar today. And before we start though, I think this is an official CNCF community group event. So, and it is subjected to all CNCF code of conduct. So be respectful of your time and also fellow participants. And without further ado, Mani, I hand it over to you.
You can come up from mute. Thank you very much, Harish. So, hello everyone, good evening, and welcome to this virtual event. As a quick introduction, my name is Mani Baradar Hosseini, and I spent the last 12 years in the integration industry and work for companies like Tipco Software, MuleSoft, and I'm currently working at Kong, one of the API lifecycle management leaders in this industry. In this event, we want to talk about design principles and basics of Envoy and why it's been adopted and used by many mesh products and companies. Our goal is to lay the foundation for the future events where we want to cover more advanced topics related to service mesh. So let's start with the agenda for today's meeting. So first we talk about what is Envoy. Then we will have a brief review of service mesh. Then we will highlight some of Envoy's key features and capabilities. And we extend a bit more about Envoy dynamic configuration capabilities. Next, we will cover some of Envoy's terminology and concepts, followed by covering Envoy admin API endpoints. And at the end, we will have a few demo scenarios to cover some of the Envoy's capabilities that we are presenting today. And if we had extra time toward the end of this event, we can take some questions, or if you could, we will possibly answer it today, or we may actually cover your questions in the following upcoming event. So let's start with what is Envoy. So Envoy is a layer 3, layer 4 proxy at its core with a layer 7 proxying capabilities. It's designed for large, modern, service-oriented architectures. It can be used as an edge proxy as well as internal proxy. Originally designed and developed by Lyft engineering team, the reason was their engineering team faced some of common problems and challenges that any organization may face when adopting microservices. For example, observability is a major challenge as the number of APIs and microservices were growing. Troubleshooting the issues gets harder and harder because developers may use different languages to implement microservices like Java, Python, Node, or Go. Each of these languages has a different capabilities when it comes to logging and generating meaningful statistics. Thus, when the issue occurs, tracing request flow and identifying the root cause of the issue becomes very challenging among all of those microservices. Just imagine that those logs they are in different format, they have different things, different capabilities, so it becomes challenging. And consistency among microservices is another challenge. Even when we push the developers to follow the best practices, for example, all services should implement logics like retry, circuit breaking, or rate limiting, or timeouts. They have to use the available libraries within those languages that they are using, but it may still fail as each framework and language handle them differently, or different team may have a different or partial implementation of those best practices. And as you can see, it is a logic that is repeating in all those microservices, but implemented using different languages or libraries. Thus, in comparison to this library approach, the out-of-process approach will be a better approach, which has no dependency on any language or frameworks, right? So these are some of the reasons why Lyft designed Envoy for their service mesh solution, which is born out of the belief that The network should be transparent to the application. When the network and application problems do occur, it should be easy to determine the source of the problem. So Lyft donated Envoy to the CNCF, and now it's a graduated CNCF project, which means this has a lot of adoption. It is adopted by many products and companies like Kuma, Istio, Consul, Mesh, GCP. GCP is actually using it as an internal load balancer recently, and AWS AppMesh, and many more. So far, we talked about what is Envoy and challenges and principle behind its design. Let's briefly talk about service mesh and how it helps to overcome some of these microservices challenges. In software architecture, a service mesh is a dedicated infrastructure layer for managing or simplifying service-to-service communication between services or microservices using array of network proxies. Or in a different terminology, or better terminology, is a better way to implement modern networking and connectivity among the different services. For example, in a service mesh implementation hosted in Kubernetes, we have a network of applications or microservices, and we can attach a sidecar proxy to each and every one of those services. Thus, we can transparently inject capabilities like service discovery, observability, traffic management, and many more to each and every one of those services, with no code modification, since it's out of process approach in comparison with the library approach. Because as you can see, like these sidecar containers, they are actually out of process, and the application can easily communicate with them. Thus we don't need to we can actually inject the capabilities in these sidecars, and we don't need any code modification. And then any of those services like A wants to talk to B, instead of going, for example, this service wants to talk to this one, instead of this service tries to figure out how it can communicate with the other service, it only knows its own local proxy, and it communicates through its local proxy. So then it will communicate with sidecar proxy, then the sidecar proxy on service A will communicate with the sidecar proxy on service B. Now we can have the logs, traces, and stats in a unified way and format, which is essential from the observability standpoints. And in this architecture, each service is only aware of the sidecar proxy that is available on the local host or its sidecar. And the network has been fully abstracted from each one of them. So this is another advantage that we have. So the developers don't have to think about which protocol I have to use to communicate with the other service. So it's all will be handled by the proxies. And the entire network topology and complexities are all hidden from the actual service implementation. So now that we talk about Envoy and service mesh, let's talk about Envoy capabilities, which makes it ideal choice for many products and companies. Envoy is designed to be very lightweight with very low latency, and at runtime, it uses a self-contained single process with multi-thread architecture that can run along any application. At its core, Envoy is the layer 3 and layer 4 proxy, which means it can be used for simply anything, bytes in, byte out, database, or anything. And it has a pluggable filter chain architecture and can be used as a layer 7 HTTP proxy thanks to this architecture that it has due to the filters. And it can actually have the routing capabilities, layer 7 routing capabilities as well, like a path-based or hostname-based routing. And it's the best in class for the observability in terms of statistics, logging and tracing capabilities with out-of-the-box support for Prometheus as well. It was the key feature when the team started to design it. And it offers advanced features and policies like load balancing, active and passive health checking, or secret breaking. And allow me to extend these two. For example, an example of active health checking is pinging a specific endpoint on a service and make sure it's returning an expected response. So in this way, you can identify that this service is faulty, this endpoint is faulty, so you will stop sending requests to that endpoint. And example of passive health checking is like outlier detection, which is monitoring or observing the service's responses. For example, we monitor the particular service and we check all of the responses. And if it returns HTTP 500 few times in a row, it will be marked unhealthy or configured. It will be marked unhealthy for a configured period of time, and no traffic will be forwarded to the service in that period of time. And another benefit of Envoy Mesh is that Envoy enforces secret breaking limits and rate limiting at the network level, as opposed to having them to configure in the code inside of each application independently. For example, you can rate limit when number of concurrent requests exceeds certain threshold. And it supports both static and dynamic configuration, and also it has the ability to hot or live restart itself. So this means that Envoy can fully reload itself in terms of configuration and code without dropping existing connections. And this is a very interesting feature, so we will cover it more in the next slide. And it can act as a universal data plane and supports any control plane typically, as long as they implement the Envoy XDS protocol and API endpoints. You can develop them in any language that you want. Oops, sorry. And the last one. Yeah, and the last one is that Envoy can support many different protocols like TCP, UDP, HTTP1, HTTP2, 3, gRPC, and many more. And so far we talk about Envoy key features and mesh, and now let's more talk about that dynamic configuration capability of the Envoy. So Envoy has a series of discovery services, which collectively called XDS. And in this case, X is like a variable that is like a placeholder for one of these services, like a CDS, which is cluster discovery service, LDS, which is listener discovery service, and ADS, which is aggregated discovery service. And the main idea behind the XDS services is that Envoy boots up with a simple bootstrap, then he can contact the management plane and say, and sends a request. For example, it says, hi, I'm Envoy on this host, this is my ID, I'm in this zone, and this is, please give me my configuration. And the interesting part here is that the management plane can do all sorts of different things before sending the configuration to the data plane. For example, because a data plane can now identify and distinguish which data plane is this one. So for example, it can send the staging configuration to the staging Envoy data plane and dev configuration to the dev Envoy data plane. And Envoy can discover its various dynamic resources by two main methods, via the file system and the query management plane. In the file system method, Envoy subscribes to a file system path and watches for its changes. So we will cover this in this demo later today. And in the query management plane method, it will initiating a gRPC stream or pulling a REST JSON URL. So this involves sending the request and receiving the response back with a specific format defined in the XDS protocol. However, this method is beyond the scope of this event and requires a management plane, and we will cover this in the future events. Now that we know Envoy and its capabilities, we can talk about Envoy key concepts and terminologies. So on a very top level, from the Envoy's perspective, downstream is actually the client application which is sending the requests. And upstreams is the backend service or APIs behind the proxy, which receives the request from the downstream. And if you look at the Envoy itself, so we have a component called listener. So we can have one or more named network locations that can be connected to by the downstream clients. It's like a proxy endpoint exposed to the client applications with a particular address and port that the clients can connect to and send a request. And then we have this concept of filter chain and filters. So when a request hits one of the listeners in the Envoy, that request goes through a set of objects called filters. Envoy filters has a pluggable chain architecture, and in order to manipulate or manage the incoming traffic, as you can see in this example, for example, I have the TCP filter as well as the HTTP filter. So on the top one, the TCP client connects to the listener, sends this request, it goes through the TCP filter, and TCP filter will get it and match it to a particular cluster. And it will go through the endpoint. And if you look at this one, the HTTP client side, we actually have a nested filter chain here. So the request goes through the listener, and then under the filter chains, we have the HTTP filter and then the router filter, which allows us, which gives us the layer 7 routing capabilities. So let's talk about what is clustering. So cluster represents a group of similar upstream endpoints and can perform load balancing and health check on each one of them. So these are the clusters, and as you can see, it has the load balancing capability. And now we need to know what are the endpoints. So endpoint represents destinations for the traffic that is sent to the cluster. So essentially, each endpoint is representing one particular backend API. And now that we cover Envoy components and terminologies, let's talk about Envoy administration API endpoints. So Envoy has a very rich admin API. There are lots of endpoints. For more information, you can actually refer to this to the Envoy documentation. And I will cover some of them in this demo. For example, the cluster, it lists out all of the configured clusters, and this information includes all the discover upstream host in each cluster along with per host statistic. And this is useful for debugging service discovery issues. Listener will list all of the listeners that we have configured, and it includes the information like the name of the listener as well as the address and the port that they are listening on. And then the config dump. Config dump is actually, it returns the entire Envoy config. So it loads the configuration from various Envoy components, and it returns a payload as a JSON serialized proto message. And it's a pretty big payload. So I will show you how we can manipulate it or how we can use this information. But technically, at any point in time, if you want to take a snapshot of that particular data plane, all you have to do is to just do a config dump. And the stats endpoint is actually showing all of the statistics, and it supports the JSON format as well as the Prometheus format out of the box. I will try to show some of them during this demo. And then the other one is the logging endpoint, which is actually this endpoint is actually can be used to see what is the current log level of the components and Envoy. And if you want to set something to debug log, for example, then you can actually use it. So before starting the demo, let me share some useful tools that I'm actually using in my demo today. So first, I'm using Docker Compose, and I'm assuming that many of us knows what is it. So the other one is actually the curl. So curl is actually a command that sends a request. Again, I'm assuming that we know, many of us know what is it and we are familiar with. It's a command tool very similar to Postman. So it lets us send the HTTP request. And then we have this JQ, which is a tool that can be used to query like a JSON object. So we can filter or query parts of the JSON objects and fetch them. And there's an interesting tool that I've recently found. Its name is Grown. And it can flatten the JSON object in a format that is compatible with the JQ filter. So for example, I will show you how this tool works. Is actually when you pass the JSON object to it, it will flatten it, and then you can actually use that like a JQ query filter. And the other tool I'm using is H2 Load. So this is a load testing tool very similar to Apache Benchmark, AB. And I'm using it in some of the scenarios in today's demo. So let's start with the first demo. In this demo, I'm using the Docker Compose to start two service, HTTP bean as an upstream, as well as my Envoy in a separate container. And I will show Envoy static configuration, as well as layer 4 and layer 7 capabilities, and the admin endpoints. So let's start with the demo. I'm hoping that you can see my terminal correctly. Okay. So first, let me start with with as I mentioned, I'm using Docker Compose, and as you can see, I have two services here. One is my Envoy, and the other one is HTTP bean, which is my upstream. And there's nothing special here. All of these codes and everything I'm using in this demo today, including the presentation slides, are on my GitHub repository. And the last slide, I will show that. And this is my Docker file. So for the static one, the only thing I'm doing is I'm making a local copy. I'm copying my static configuration into etc envoy YAML, and then it just starts the envoy with this configuration. So let's have a look at the static configuration file. And this is the most important part. So at the top, you can see that this is the admin API configuration. So for example, this is say like the access log path for the admin API, and then the address that admin API is listening for which particular data plane. And as you can see, I have this static resource. And before going through the static resource, as a reminder, let me bring back this slide. I put it here. So as you can see, we have a listener, filter chain, and a series of filters in each filter chain plus cluster and the endpoints. So now let's have a look at our static configuration file. This is my listener. This is my listener. I'm calling it like listener HTTP. It's listening on all of the network interfaces on the port 10,000. And this is my filter chain. Under my filter chain, I have the HTTP connection manager filter. So this actually indicates that this is the layer 7. This injects the layer 7 capabilities for us now. And under that, you can see there is a nested HTTP filter, which is my HTTP router, and this is my routing rule. So I'm saying if any request comes with this path /HTTP bean, replace the path with the / and send it to this cluster. Same goes here. So this is my TCP listener. It listens on the all network interfaces on port 11,000. And as you can see under the filter chain, I'm actually applying my TCP filter this time. So this is a difference. You see here, I have a TCP proxy. In here, I have a HTTP connection manager filter. And under that, because this is now just a socket connection, it's a layer 4 proxying. So what we do is we receive it and we actually send it to the cluster. So this is my endpoint cluster. This is my the cluster that I'm routing this traffic to. And this is the cluster configuration. As you can see, the cluster configuration has a load balancing capabilities, and I have this series of the endpoints, which currently I have only one endpoint here. And this is HTTP bean, hostname, and listening on port 80. One thing that I wanted to highlight here as well is that one capability that Envoy let us do is for the filters, one thing we can do is to use the stat prefix. And I will show you, it will become very handy because now we can trace the request from the listener to the filter and then to the cluster. So I give this one, all of the statistics that is collected under this filter will have this name, my HTTP clients. And same for here, the stat prefix is my TCP clients. So let's go ahead and close, oops, save. Close this one. So let me go ahead and now start this environment. So let's see, static starts. So it actually starts, it will take a while for the Docker Compose to start the server, to build the images and then start the services. It's starting them. And TCPS, I have them both running. So let me now try to exec. Now I'm connecting to my Envoy container. And if I show you the processes, you will see that the Envoy is actually running in a single process. And it's actually using this configuration file, which is the same one. This is the same static configuration file that I showed earlier. So in terms of testing this service, let's have a look at the admin API first. So this is the Envoy admin API. So if we look at the listeners, we can see that we have HTTP listener, we have a TCP listener, and it's listening, subscribing to all network interfaces on its host. And this one is listening on port 10,000, the other one on 11,000. And now let's send the request to the TCP endpoint that we have. Yep. So now we send a request to our TCP endpoint, and now let's go back to the admin GUI and have a look at the statistics. So this is the stats, and let me search for this one. So you can, as you can see, what it says. So remember that downstream represents the client application. So it says that it receives one connection, the CX means connection. So it receives one connection from the downstream on this listener, 11,000 listener. And if we now look at now it will go to that TCP filter from this point. So if we look at here, so this is one of the key capabilities of Envoy. So you have very fine-grained statistics. So you can see that inside of the TCP filter, we had one connections there as well. And it actually allows you to trace the request to the end. And now from this point on, it will go to the cluster. And if we check the cluster side of it, you can see that the cluster, which is facing the upstream, it's using the request hits the cluster HTTP bean, and it's our upstream, and we had one connection there as well. And now, one more thing that you can see here is actually the number of the calls to the admin API itself. So far we had 4 calls here, and if I keep refreshing it, it's keep increasing, as you can see. Now let's send the HTTP. Now let's send the request to our layer 7 proxy endpoint. So this is our this is the one with our HTTP filter. And in contrast, I want you to notice one thing. So this backend service that I have, it actually prints all the headers that it receives from Envoy. If you notice that this is the TCP one receives the standard headers, nothing extra. But the other one that goes to the HTTP filter is actually receiving some extra HTTP header information as well. For example, this one says X Envoy original path was /HTTP being get /get. But as you notice, we had that we updated all of the prefix and put it back to the /. So we dropped it. So the actual service still received this request URL. So this is something that you can see here. And let me send one request that is actually causing error, because I want to show you the HTTP statistics. So this is a wrong endpoint. So it actually returns 404. So, and now, oops. If I go back to the admin GUI and search for this one. So in here, let me refresh it. Yeah. So I'm hoping that is visible. So you can see that there was a 200 request from the downstream, and the other one receives 400. So there's actually a breakdown here as well, and then you can actually get a lot of more statistics. So it's a very rich feature of Envoy, and what I would recommend you is actually try to go ahead and read this documentation with regarding the statistic stats endpoint. For example, another feature is I can actually apply a filter. So this is, I'm hitting the same stats endpoint, and I'm now applying the filter to get the total number of requests for the upstream. And yep, there you go, you get it. So this is the total number of requests, which is going to my upstream HTTP bean. And the other one that I wanted to show you guys is like the Prometheus one. So we can actually say, I want it in the Prometheus format, and you can get all of the statistics in the Prometheus format, as well as you can say, I want to have it in JSON. And yeah, it comes as a big JSON now. And the other endpoint that I wanted to show is like the config dump itself. And let's have a look at this endpoint. So, okay, so this is a very large JSON payload. And this is the part that is actually useful to use this to ground. So now I'm piping the output to the ground. As you can see, it flattens it into this format. And then, for example, if I use, for example, here, where is it? There you go, routes. I can pick it. And for those of you who are familiar with the JQ format, so you will like this too. So this is JQ and I use it as a filter, and there you go. So now I can only get my HTTP routing rules out of that entire big config dump payload. And you can develop a lot of more like configurations like this. For example, you can have, you can get all of your static listeners, and this is like printing all the static listeners I have. So this is my TCP listener with this configuration and filter chain. And again, I have the HTTP one on the top here. This is my HTTP listener with these filter chains and filters that it has. So I think that should be enough for the static part. Let me stop this environment. This is static, stop. And let's go back to the diagram. So as you can see in the configurations, Envoy always have a listener, and under the listener, we can have a filter chain. And under the filter chain, for example, we can filter the traffic based on what we want. You can go to the documentation and see the list of filters that it has. And finally, within the filter chain, you can point into the cluster, and from cluster, the endpoints configurations. So let's go to the second demo. So in this demo, and all of the following demos, we will be using Docker Compose to start two HTTP bin instances as our upstream services and Envoy itself. So in this demo, we will use dynamic configuration capabilities using file system method, where Envoy subscribe to the changes on the files located on the each of the container. So it will subscribe to the location of the LDS as well as the CDS. So this will help Envoy to load these listener configurations, and this one is helping Envoy to for the cluster discovery service. So it's actually helping Envoy to populate these dynamic cluster configurations. So let's have a look at how this configuration look like. So if we look at, oops, no, if we look at the Envoy dynamic configuration, if you look at the Envoy dynamic configuration file, we will notice that it has a dynamic resource component here. Again, this is our admin administration API configuration. It's like an admin access logpad, as well as the where is it listening and which port it's using. If you notice here, there's another information, which is the node information. So this is the actual, it is very useful, especially in the query management plane method, because in this method, the data plane can actually advertise who he is. Like it will say, oh, hey, this is my ID, I'm ID1, I'm in this cluster, and this is my region, this is my zone, this is my subzone. So it actually helps the management plane to distinguish this data plane in order to give it the proper configuration tailored for this particular data plane. And as you can see here, so I have only the dynamic resource. I no longer have the static resource. So ideally, if I had the management plane, I could actually put it under my static resources. I could configure that this is my management plane. So when the Envoy starts up, it can go ahead and make a query to this management plane and say, okay, give me my configuration. But this, I'm using file method. So I'm only have a dynamic resource here, and I have configured my listener discovery service to subscribe to the change events on this path, and the cluster discovery service to subscribe to the change events on this file. So what's going to happen is that during this demo, I'm going to keep updating this file to the different configs, and I will show you that Envoy can actually keep reloading it, and there is no restart. It's keep reloading it, and you can see that we can actually configure it dynamically. So let me go back to clear, and let me start the environment. So it's Docker Compose, dynamic research starts. So it's going to be the images and start the services. Perfect. So DC yes, Yep, as you can see, this is my Envoy, and I have like this HTTP bean 1, 2, and service 1 as well. So I have these services as well. So now let me, okay. So first, let's just connect to the container. And if we go to this OPT Envoy, we can see all the configuration files there. And let me show you this one. So there's nothing special on the Docker image for, okay, so this is the Docker compose for the dynamic configuration. And as you can see, so I have my Envoy HTTP bean 1, HTTP bean 2, and the service 1, but the key thing is here. So as you can see, I'm copying my Envoy dynamic YAML to this location, the one that I just showed you earlier. And everything under this config folder, I'm copying it under the OPT Envoy. And this is how my configurations are already here, all of my files. So, excuse me. So let me start by sending a request to the service that we have. So first, if we look at here, we can see under the listeners, we only have one listener, and this is our HTTP listener. And if you look at under the clusters, we only have one cluster, and this is for service 1 cluster. So let's go ahead and send this request. So I'm sending it to the 10,000, which is my listener, HTTP, layer 7 listener, HTTP listener, and service 1. There you go. So this service, it receives whatever header it gets and it echoes it back. So we receive a successful response from this service. And let me now start to show you the Envoy logs. So these are the Envoy logs. And now I want to go ahead and update the cluster definitions. So let me show you. So as you can see, I've built up all of these JQ filters for myself, so I can just query things and get the information I want. So as you can see, I only have one cluster at this point. This is service 1 cluster. Now I'm going to update my cluster configuration. Okay, so I'm moving the CDS2 YAML to CDS. So I'm just, it's because it's listening on the event changes on this file. So let's go ahead and do it. And as you can see, it actually updated the cluster and it added a new member. So if we check here, now we have HTTP bean as well as the service 1 cluster. And this is what it says here as well. So it's actually, it added 2 clusters. So one of them is unchanged and the other one is updated. So now, let's go ahead and get the number of get the listener configuration. So as you can see, currently, I only have a routing configuration for service 1. I don't have any routing configuration. Now we added HTTP bean cluster. So we need to add its routing configuration. So I'm going to update the LDS. So I'm saying move LDS to YAML to LDS.YAML. There you go. It updated the HTTP listener that we have. And if I send this request again, now you can see I have under the routing configuration, I have service 1, service run route, and it actually sends the traffic to the service 1 cluster, and then HTTP bean route, which is sending the traffic to this cluster. So let's go ahead and test these services. So yeah, now I can actually, I'm sending it to the same endpoint as you've seen before in the static one. So it's the same one. So yep, I can hit this one and I can still hit my service 1. Yep, this one is also successful. Now, what I want to do is I want to dynamically add a new listener, which is my TCP listener. So let me show you the listener names that we have. So again, I'm going to use this API. So as you can see, I'm configuring and this JQ, I'm filtering under the configs, dynamic listeners, and I'm getting all of the names. And I can see there's only one HTTP listener. So let me go ahead and apply the file. And yeah, this would be the TCP one. Yep, I'll use TCP to here. So now I'm updating it. And as you can see, now I have HTTP listener as well as TCP listener. And we can hit the same endpoint, and we can see now we have two different listeners, and we know that like the TCP listener is pointing to the same service. So we can go ahead and hit our TCP endpoint. And there you go. This is also working. And as you can see, because it's TCP, it no longer has that origin Envoy original path. So that's it for this demo. And from this point, we can move to the next demo, which is, talking about circuit breaker. So in this demo, I want to show you the circuit breaker capability of Envoy. The number of, for example, when a number of requests goes above a certain threshold, it will trigger the circuit breaker and returns HTTP 503, as you can see with this header, X Envoy overload true. So for this configuration, this is my circuit breaker configuration, and this is the cluster level configuration. So I would say like under the cluster configuration, I will say I have a circuit breaker for this particular cluster, cluster, and the threshold is maximum connections 1, maximum request 1. And let's go ahead and have a look at the, let's go ahead and have a look at, where's the one? Yeah. So close, 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 close. And this is my, for example, circuit breaker. So as you can see in the CDS file, I'm only sending, so this is those proto formats that Envoy has. So even if I was doing a query to the management plane, the response should come in this format. This is that format that Envoy defines. And as you can see, like in here, I'm saying like, this is my cluster one, this is my cluster one, this is my HTTP bean cluster. And then under this cluster, I can see that I have my endpoint, HTTP bean one endpoint. And now I have defined my circuit breaker here with the maximum connection 1 and the maximum request 1. So let's go ahead and apply the configuration first. So to apply the configuration, I want to update the CDS circuit breaker. There you go. So I have updated the CDS, and first, one thing I wanted to show you is now I'm using this logging API to set the HTTP to the debug logging. So if I make a hit to this admin endpoint, you will see that it says the HTTP to the debug because I wanted to start printing the HTTP header. So you can see that the HTTP status is 200, and there you go. So we can trace the request as going through. So let's send a load. So in here, I'm sending a load with more than one concurrency. It's 10 requests. So some of them should start getting that 503. And as you notice here, we can see that, yep, there you go. This one got 503, this one got 503. And if you look at the overall statistics here, in total, we had 10 requests, 4 of them were successful, and 6 of them received 500. So this is how the circuit breaker works, and then we can actually use it for applying rate limiting. It has many more configurations and scenarios. So again, I do recommend you to refer to the documentation to see all of them. And let me move to the next demo. So in this demo, I will cover outlier detection, which is a form of passive health checking. Envoy's outlier detection can eject a faulty node or endpoint from the cluster's load balancer based on the conditions that we configure. So for example, when one of the HTTP bean 1 or HTTP bean 2 is stopped after consecutive 500 when we stop it, it will start returning after 2 consecutive 500 responses that we receive. It will be ejected from the cluster load balancer for the configured period of time, like it's a 60 seconds in this point. So as this is a form of the passive health checking, and we are only observing the responses. So imagine that now that we have stopped this endpoint, and for the 2 consecutive time it returns 500, each time client receives the error. After this, we eject this endpoint from this load balancer, and the rest of the request will only go to the healthy endpoint. So we will see that for the period of 60 seconds, all of the requests will start going there. So after the first batch that we have some errors, all of the others will go through the second endpoint, and it should be healthy. Again, after 60 seconds, it will add this endpoint back to the load balancer. And by that point, if we haven't fixed the service problem, again, the first two requests to that endpoint will fail. Rest of them will be successful because it will eject it again for the next period of 60 seconds. So this is how the configuration look like. Again, this is for the outlier detection, it's in the cluster level. And allow me to share this config. So this is the outlier detection config. And as you can see, so this is my CDS file. And in this one, now I've added the outlier detection. I'm saying if I get consecutive 500 XX for 2 times, you will eject it, and I have set it to the 40 second for this one. And as you can see, I have for my load balancer, I have 2 endpoints, HTTP being 1 and HTTP being 2. So I'm going to fail one of them to reproduce the issue that to scenario. So let me go ahead and now, okay, give me 1 second. Now I need to copy the CDS outlier, right? Yeah. Now I'm moving the CDS outlier again, and I'm replacing the existing one. Again, it's been loaded, and I'm sending the load. So the first load I'm sending, everything is healthy. So we should see 10 out of 10. Yep, 10 out of 10 gets 200. There is no error. And if you look at the health flag under the cluster, so I'm using admin API clusters endpoint. I can see that both of the HTTP bean endpoints are marked healthy. So they are both healthy. So let me start this one with, actually, let's have it. It's good to have it. We still want it. Now let me stop one of them. DC Docker compose start HTTP bean 1, for example. Yep, HTTP bean 1 is now exited. Now I'm sending the first batch of load. So this is exactly expected. 2 of them failed because after 2 consecutive failures, it's been ejected, and 8 of them are successful. And now if we look at the second batch, now for the period of that 60 second or 40 second, everything will be 100% successful because now that outlier detection has detected it and is ejecting it. So let's have a look at the health flag, and you can see for the health flag for this particular endpoint, it says failed outlier check. So let's check it for let me send another batch, and you will see again, 10 out of 10 is healthy because this is still ejected, but eventually it will add it back. And so after that, when it adds it back, we will get the error again if the service is not healthy during this time. So yes, there you go. You see, it's healthy again. So if I send the request again, I send the load again. So 2 of them will fail, and there I get 2 HTTP 500s and 200 responses. And if you look at the health flags, again, it is checked with the failed outlier check. So it's been flagged again. And as you noticed, so this is a passive health checking, so the clients can still receive the error HTTP 500s. Let me now start the service back. This is start HTTP bean 1. And let's go with the active health check scenario, which is the next demo. There you go. So what I want to show you here is the active health check capabilities of Envoy. So, and in this scenario, Envoy will periodically perform health checks on a specific endpoint, on the upstream side, and for the microservices. it actually hits the endpoints on these microservices. And if it's not healthy, based on the configurations, it will actually proactively eject it from the load balancer, and it will stop sending any request to this unhealthy endpoint. So if you look at the configuration here for the health check, again, this is a cluster level configuration. And if we look at these health checks, we say on the intervals of every 10 seconds, and this is my unhealthy threshold. So if one request fails to this endpoint, I will mark it unhealthy, even one is enough. And before marking it healthy again, at least I want two consecutive successful requests. And we can have two different health checks here, TCP health check or HTTP health check. So in this point, I'm using HTTP health check. And I will say like hit each of the endpoints on this URL /get, and the expected HTTP header status is 200. If you configure TCP, it will just make sure that the TCP connection is successful. So let's go with this last scenario. And first, let me show you. So this is my health check. And as you can see, again, so under my HTTP bean cluster, I'm configuring my health check configuration, and I'm saying like I'm expecting the status to be between the range of 200 and 299. And my intervals are 10 seconds. And again, like unhealthy threshold 1, healthy threshold 2. So let's go ahead and apply this one. And let me quickly check. Did I start that service? TCPS. Yep. All services are running. And again, if we check the health flags under the cluster for each of the endpoints, we will see that both of the HTTP bean endpoints are marked healthy. Now, what I'm going to do is I'm going to stop one of them. So DC stop HTTP bean 2, maybe this time, yep. We will stop it and we wait for some time, and eventually it will detect that it's unhealthy. There you go. So now it actually marked the HTTP bean 2 unhealthy, and it says that it failed active health check, and it's currently an active health check timeout. So now if I send any kind of loads, I will not receive any error in this period of time. So there you go. 10 out of 10 are all receiving HTTP 200, and they're all working fine. And now if I start that service back again, this is start HTTP bean 2. To CPS. Yeah, it's back up and running. And let's check the health check. So eventually it will mark it back healthy again, because remember that it needs to get to a successful response from that. There you go. Now it's been marked healthy, so that means like we are routing traffic there again. So that's it for today's demo, and I've covered all of the topics that I've prepared. All of the contents are shared in GitHub. So this is my GitHub link, and everything is under this GitHub repository. And that's thank you very much.
Many thanks for this. There is a question posted. I'll read that out for you. Is it possible to customize the Envoy capabilities? Does it have capabilities like NGINX to write custom modules? A use case, for example, is enabling MTLS with client using certificate signature validation and a conditional processing and routing. So the question is more around extension of Envoy capability.
Yeah. Well, it actually does support MTLS. So these are more advanced topics that I will cover in the future events. So it does actually support it, and it actually has a lot of configurations and different filters for that. So that is also supported. Yes, I will cover it in probably one of the next meetups. The next one will be the one that I want to show you how it actually uses that query management plane method. And I will try to actually cover this case in that as well. That's a very good.
Right. All right. Thanks.
Yeah.
Thanks, Mani. I think if there are no questions anymore, thanks everyone for joining. So you have a wonderful holidays ahead, and have a nice evening.
Yeah. Thank you very much.